This paper was written on June 3rd, 2016. The accretion principle of planet formation and cellular evolution. It's already over a year old. Says here, a simple principle is provided to explain accretion in astrophysics according to the general theory. Now, for those that know this already, stars cool and collapse and become what are called planets. That obviously. Therefore, the accretion principle rests on two fundamental measurable aspects, being that the star collapses and cools and forms the planet. Number one, the stronger the gravitational field, the more objects can be accreted and captured. It's as simple as that. The net is really, really big, if you will. And number two, the more surface area of the object, the more objects can impact it and accrete together in the central regions over time. Obviously, the star would capture meteorites and other various material and transport it to the central regions of the star, forming the planet. With these two fundamental observations, it can be reasoned that the accretion principle can be worded as such. The greater the surface area and stronger the gravitational field, the more an astrophysical body can accrete material in outer space. In different wording, to counter the pseudoscience currently accepted by establishment, this is a different wording for the same principle. The smaller the surface area and weaker the gravitational field, the less an astrophysical body can accrete material in outer space. This means that the only bodies that can do any appreciable amount of accretion are those bodies which possess large surface areas and large gravitational fields. This renders the protoplanetary disk and nebula hypothesis and core accretion models currently accepted by establishment invalid. The correct sequence of events is that big objects, stars, capture and absorb smaller objects, which then collect material, forming huge objects in their centers. This is the planet formation process itself. Not small objects capture each other to make big objects. So establishment has it backwards with this as well. Not only their ages are backwards, but their methods are backwards too. They believe that small, tiny objects that have essentially no gravitational field and incredibly minuscule surface areas all magically know where to find each other in outer space. That's absurd. To form something as massive as the Earth, you needed an even more massive object to capture the material. Think about it. If an object like the sun is really, really, really big, it will absorb tiny 1 centimeter, 1 kilometer sized particles and absorb all that and collect it all into the center. It doesn't work without a star. You just don't have material that's 1 centimeter in diameter traveling at Keplerian velocities, which are above and beyond the velocities of bullets coming out of rifles, know exactly where to clump together in outer space. It doesn't work like that. You can't have material clumped together in that fashion, because there's no surface area. They'll pass right past each other, and even if 1 centimeter sized particles did clump together, they would smash apart and make even smaller pieces. You can't form a planet like that. It absolutely needs to have an object that can collect the material with a giant gravitational field and with a giant surface area, so it can pull in more material. This also means all the large objects in outer space will no longer shine, were once a part of even larger objects, or even themselves very, very large like the sun. They're the cores of the dead stars, obviously. Just so the reader is aware of the differences, how much matter could a 1 kilometer sized asteroid accrete versus the Earth? How much matter could the sun accrete versus the Earth? This question is for mathematicians to calculate. The philosophy is already sound. Essentially, it's the difference between having a large net when you go fishing, like a cast net. You can throw the cast net out and you increase the odds for catching fish. But what astronomers do is they say, well, the net doesn't even really need to be big at all. You don't even need to have a net to begin with. I mean, relative size wise is what they do, is they think the fish just collect themselves without having a net even in place to capture them. It's really weird reasoning, and I don't understand why they've even accepted that type of reasoning. It's, when you look at it on the face of it, it doesn't make any sense at all. I guess they just accepted it because they cannot have stars as a location for accretion after the fact. In other words, they have to have a planet forming in situ or as it is. It couldn't have been very, 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 very large, and it had to have formed with material that was already preformed to begin with, which is even stranger. Like they say, rocks 1 centimeter and up to 1 kilometer big just clump together. Well, what process formed those rocks? Rocks form an incredibly high heat and high pressure. And high heat and high pressure doesn't exist in the vacuum. How the hell do you have high pressure and high heat preforming rocks which then clump together, minus the gravitational field or even the surface area to know where the other rocks are? It doesn't make any sense at all. So that's why I had to put this accretion principle paper up there. I'll go ahead and link this to the bottom of the page. Baz, I know I told you I would put the atmosphere thicknesses of different objects, and go ahead and email that to you. I better get busy on that. I've been slacking. But alright, you guys, that's all for today. Take it easy.